Networking Series. Hi friends, welcome to our comprehensive guide on the OSI, Open Systems Interconnection, layer. In this video, we'll be diving deep into the 7 layers of the OSI model and exploring their functions and interactions. First, we want to know why we use the OSI layer model in networking. Standardization. The OSI model provides a common language and standard for network communication, which allows different vendors and developers to create compatible devices and software. Modularization. Each layer of the OSI model has a specific set of functions, which makes it easier to develop, troubleshoot, and maintain network protocols and applications. Flexibility. The OSI model allows for the creation of custom protocols and applications that can operate at different layers of the model, depending on the specific needs of the network. Troubleshooting. The layered approach of the OSI model makes it easier to identify and isolate network issues, as each layer can be individually tested and evaluated. The sentence, "Please do not throw sausage pizza away," is a mnemonic device used to remember the 7 layers of the OSI model, in order from bottom to top. The top layer is application, presentation, session, transport, network, data link. Bottom layer is physical. The Open Systems Interconnection (OSI) model is a way to represent how devices communicate with one another. It consists of 7 layers. Layer 1, the physical layer, is the foundation of the OSI model. It deals with the physical transmission of data over the network. This layer defines the physical characteristics of the network, including the cables, connectors, voltage levels, and data rates. It also handles the modulation and demodulation of signals. Some common devices operating at this layer include Ethernet cables, hubs, and repeaters. The data unit for this layer is bits. Moving on to layer 2, the data link layer. This layer provides reliable data transfer across the physical network. It transforms the raw bit stream into manageable units called frames. The data link layer is responsible for error detection and correction, as well as flow control. Switches and bridges operate at this layer, ensuring efficient data transmission within a local area network. The data unit for this layer is frames. Layer 3, the network layer, is all about routing and logical addressing. It determines the best path for data packets to reach their destination across different networks. Routers and layer 3 switches play a vital role at this layer, as they make decisions based on logical addressing information. The Internet Protocol, IP, is the key protocol used at the network layer. The data unit for this layer is packets. Now, let's explore layer 4, the transport layer. This layer ensures reliable end-to-end communication between source and destination hosts. It breaks down the data received from the upper layers into smaller segments, ensuring they are delivered correctly and in the right order. The transport layer handles error recovery, flow control, and congestion avoidance. Two popular protocols at this layer are TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. The data unit for this layer is segments. Next up is layer 5, the session layer. This layer establishes, maintains, and terminates connections between applications. It manages the dialogues or sessions, enabling communication between different applications. The session layer handles session synchronization, checkpointing, and recovery. Protocols like NetBIOS and RPC, Remote Procedure Call, operate at this layer. The data unit for this layer is messages. Layer 6, the presentation layer, focuses on data formatting and representation. It ensures that data from the application layer is transformed into a format understandable by the receiving application. This layer handles tasks such as data encryption, compression, and data format conversion. Protocols like SSL, Secure Sockets Layer, and TLS, Transport Layer Security, operate at this layer, providing secure communication. The data unit for this layer is data. Finally, we reach layer 7, the application layer. This is the layer that interacts directly with users and provides services to applications. It enables user access to network resources and defines protocols for application services such as email, file transfer, and remote access. Protocols like HTTP, FTP, and SMTP operate at this layer, making it a crucial layer for end-user communication. The data unit for this layer is data. And that's a wrap on our comprehensive guide on the OSI layer. We hope you found this video helpful in understanding the functions and interactions of each of the 7 layers. Remember, the OSI model serves as a framework for communication within a network, while the TCP/IP protocol suite is the most commonly used set of protocols for communication over the internet. That's it for today's video. I hope you found it informative and useful. If you have any other doubts about any section of networking, please feel free to leave a comment. Thank you for watching, and I look forward to seeing you in the next video.